What's up? So, I'm going to tell you how you can flash your RDNA4 graphics card's Eprom to offset voltages, set current limits, and the like. So what you're going to need is this file here. It's called RDNA4.sh. To get that, you can simply Google RDNA4 Eprom, and it's the first thing that comes up. Or just go to the link that I put there. What you want is to go here, then you go down, and it is this one down here, the GitLab power limit removal raw main RDNA4.sh. To get that, you open link in new tab, and then you go Control S, and you want to save it as an all file, and then remove the text .txt off the end of it. And I've already got it, so I don't need it. But once you do that, then you need to get Linux, which I have on this USB stick here. I have Lubuntu because it's like the smallest one, and I only have a 4 gig USB stick. I tried a lighter one, it didn't actually work because it was missing some of the driver files. Don't actually need that. Yep, so I'm going to reboot into Linux and show you what to do. Right, so I've been mashing F12. I'm now on the boot driver screen. I want to go to my USB stick. And once I click on that, it's going to take me to this Ventoy Lubuntu. You want this version because apparently the newer ones don't work with this script. So I'll just press enter, enter, then it'll bring me here, enter again. So now I'm in like a trial mode of Lubuntu. I'm not actually going to install it, I don't want to run this because I run Windows, because that's what I do. Oh, so let's wait for this to load up. Nice. So now that we're here, we go try Lubuntu, and then right down this bottom left corner, once it works, you just type terminal or most of terminal. Click on Q terminal. It brings up this. So you want to type out chmod space plus x space, just like that, and then you want to go to your file system here and go to the drive that has this on it, RDNA4.sh, which we got earlier. Drag and drop it here, click on the terminal box, press enter, and then you write sudo sudo, and then you go RDNA4 -m. That is the line that gives you the menu for the script. Press enter. It'll download all the modules it needs, and once it does that, you're free to do whatever you want. You know, within reason. Don't break it. But I'll give you some, I guess, I don't know, I'll give you some ideas of what you should set, since I've been kind of testing it and messing around with it. So I'm going to go modify TBP and TDC limits 1. So I have my current limit in half right now because it's my daily one. So I'm going to press 2, which custom limit scaler, go 1.5. Nice, enter. Sick. That is 1.5 times the current. I then press 1, and then that will write it to the EEPROM for that part, and it says my stock limit is currently 340 watts, and it's offering to do 408 watts. But that's not quite enough for what I want to do. 400 watts is actually a really good daily limit, but I'm just going to set like a bench run, so I'll just go 4, set limits, I'll go 440, and then I'll add the 10% on from the drivers later. So I go 3, and we'll write that to the thing, increase your limit by 100 watts. What this does is offsets it, so in the drivers, it will show 100 watts less power than what it's actually pulling, so you'll have to adjust stuff in hardware info and stuff like that. Then I'm going to modify VID offsets too. These are my daily offsets. I've undervolted the VRAM, the SoC, and just left. Oh yes, some graphics core VIDs are +5 default. I don't know why. I'm just gonna go 1 and go plus 50. Plus 50 is fine. And then gonna go 2 plus 0. You don't really have to overvolt the SoC on these, it doesn't really do much. VRAM you gotta be careful about, because if you change the voltage too much, it crashes. So I'm gonna go 125, and then I'm gonna move it up in 25 millivolt increments. So just let this do all this. Right, the EPROM can be written to, from my experience tuning thousands of times. I don't know if these are any different to the ones you get in a Subaru or something, you know, the ECU fucking flash thing. What was it? -100. Nice. And then go 5 again. We've got to go back. Press 0, go back, and then you go press 3. Permanently save mods. This will write these to the EPROM and make sure they don't. Well, they're already written to the EPROM. This will make sure it's not undone. When you go to Windows, type yes, Y-E-S, yes, enter. Nice, we're done, exit. So now you've done that, you can go back to Windows, and if you want to use Linux again, up to you, I don't care. Welcome back. So, welcome back to my computer. Now you may see something strange. Damn, my graphics card is pulling 4 watts at idle. That's crazy. It's not doing that. What you want to do is go to hardware info. So that you can customize all the offsets there. That's on my other screen. But basically, I'll drag it over. Basically what you want to do is find your graphics card's maximum power and that, so these two here, and the board limit, right click, customize, and you go, because we've added 100 watts to it, plus 100, set. Damn. That's lovely. So now the idle power is going to read incorrectly, obviously, because we're not actually idling at 100, what is this, 139 watts. Our actual power limit is, in fact, 330 watts. So that's lovely. So because I've put a voltage offset in, you can still tune all your voltage offsets with this, but I'm just going to put, say, a 40 millivolt offset. Run maximum frequency, and just because I've got the setup for benching, right? That's why I did the 400 watts, 460 watts. I'm just going to run, yeet the fans, yeet the power limit. 2750 is my maximum memory overclock without doing anything crazy. Let's run 3D Mark. Welcome to Phone Land. So, I'm gonna run Steel Nomad because that's just a benchmark, I guess. I've got it in bench mode, got 4,400 RPM of fans, got all the numbers and such. You know, okay, let's run this, I guess. So I've just input values that I know are like stable, solid, just for a bench, because I think it's the middle of summer, so I wouldn't be able to run this daily. It gets hotter than I'd like it to, which is, you know, not that nice. This current is going to be incorrect, I am pretty sure, and this voltage is also going to be incorrect because we'll put the offset. You can try using the offset in here we go. You can try putting the offset in. Damn, we are drawing 460. Come on, focus. Gee, 462 watts exactly. Memory J temp is rocketed to 84. Hotspot is at 100 degrees. My case fans are pretty low right now, so I definitely could improve the airflow by opening the case, but this is just an example. For someone with actual cooling, not just the old stock gigabyte card, you can definitely get away with doing something pretty crazy. Frequency we're hitting 3.2 throughout the entire bench, just solid, which is actually very rare for this benchmark. Normally you'd see barely just over 3k. Let's see if the score actually adds up. Yeah, temps rocket up, but I've removed the limits, and we got 8,000. I do have a bunch of stuff open. I do have all this. Don't know if that affects the score, but you know, it's pretty solid. I'd like to think. It says it's solid. My best one's 8.3, I think, but that was obviously in better thermal conditions than maximum hotspot temperature. But yeah, so you can input any values you want into that within reason. Yo, so if we open this on 3D Mark's website, average clock frequency 3.2. That's pretty good. Memory clock's pretty standard. I can compare that to a power limited run I've done earlier. I think it was about 7. Yeah, that looks like it. 7.6, 2750 memory, 3 gigahertz average. Yeah, just under 3 average clock, 7.6. And for the price of almost melting your silicon and putting it on the thermal limits, you too can get 5% more FPS. Wow.